Yes, running the feeder wire from the main distribution panel and the ground wire from the UPS in the same EMT conduit is permissible, provided certain conditions are met according to the National Electrical Code, specifically Article 300.20c. It is essential to ensure proper bonding. The ground wire must be bonded to the EMT conduit at both ends of the conduit run. This is typically achieved using grounding bushings or bonding clamps to establish a secure electrical connection between the ground wire and the metal conduit. Conduit size is also very important. The EMT conduit must be adequately sized to accommodate all conductors contained within it, including the feeder wires, the ground wire, and any other conductors that may be present. This ensures that the conductors are not overcrowded, which could lead to overheating or insulation damage. Wire insulation is important as well. The feeder wires and the ground wire must be properly insulated to prevent electrical shorts or damage to the conduit itself. Proper insulation helps to contain the electrical current within the conductors and prevents unintended contact with the grounded conduit. A conductive coating is also needed. The EMT conduit must have a conductive coating, such as zinc or aluminum, to provide a continuous grounding path along its length. This coating ensures that the conduit itself can effectively conduct fault current back to the source in the event of an electrical fault. Firstly, regarding bonding, the primary purpose of bonding the ground wire to the EMT conduit at both ends is to create a low impedance path for fault current to flow back to the source in the event of a ground fault. This low impedance path ensures that the overcurrent protective device, such as a circuit breaker or fuse, will quickly trip and de-energize the circuit, minimizing the risk of electrical shock or fire. The use of grounding bushings or bonding clamps is crucial for achieving a reliable and effective bond. These devices provide a secure mechanical and electrical connection between the ground wire and the conduit, ensuring that the ground wire is properly grounded. Secondly, with the conduit size, the NEC specifies the maximum number and size of conductors that can be installed in a particular size of conduit. These requirements are outlined in Chapter 9 of the NEC, which provides tables and guidelines for determining the appropriate conduit size based on the size and number of conductors being installed. It is important to consult these tables and guidelines to ensure that the EMT conduit is large enough to accommodate all of the conductors without overcrowding. Thirdly, as for wire insulation, the type of insulation used for the feeder wires and the ground wire must be appropriate for the voltage and temperature conditions of the installation. Common types of insulation include THHN, THWN, and XHHW. These insulation types are designed to withstand the heat and moisture that may be present in electrical installations. It is important to select the appropriate insulation type based on the specific requirements of the installation to ensure that the wires are properly protected from damage. Fourthly, regarding conductive coating, the conductive coating on the EMT conduit serves to provide a continuous grounding path along the length of the conduit. This is important because it ensures that the conduit itself can effectively conduct fault current back to the source in the event of an electrical fault. A conductive coating also helps to protect the conduit from corrosion, which can degrade its grounding capabilities over time. While it is acceptable to run the feeder wire and the ground wire in the same EMT conduit, it is generally recommended to use a separate conduit for the ground wire if possible. This provides a more dedicated grounding path, which can improve the overall effectiveness of the grounding system. A dedicated grounding path ensures that fault current has a clear and unobstructed path back to the source, which can help to minimize the risk of electrical shock or fire. The grounding method described, where the ground wire is terminated back at the main distribution panel, is an acceptable practice. This ensures that the grounding system is properly connected to the main grounded electrode system of the building. It is important to follow all applicable local electrical codes and regulations when installing the conduit and wiring. Local electrical codes may have additional requirements or restrictions that must be followed in addition to the requirements of the NEC. It is always a good idea to consult with a qualified electrician or electrical inspector to ensure that the installation is compliant with all applicable codes and regulations.